Hi, my computer froze up on me halfway through the video, so I'm going to go back through the notes, but they are already written out. So we are talking about probability and odds today. Probability is what you want over what's possible. So the number of outcomes in an event happening, the event that you want to occur over the total possible sample space. So you want to win. You play 40 games. Your total sample space is 40 games. How many of those games did you win? 20, 25, 30? How many, what you want over what's possible. The complement of an event is not happening. So the probability of what you want happening plus the probability of the complement, what you don't want, so winning and losing, is going to be a total of 1. Now, you can have probability that is 0%. It's impossible for it to occur. What's the probability that I'm going to have a student that's 28 years old in my class? 0%. What's the probability that one of my students is going to be under the age of 18? 100%. What's the probability that I have a student that is 17 in my class? Probably pretty good, somewhere between 0 and 1, right? 50%, half a percent, something like that. Now, we have all this information here. Sock drawer contains single unmatched socks, 19 white, 8 black, 5 are blue. If one sock is chosen at random, so how many socks do I have total? 19, 8, and 5. I have a total of 32 socks. I'm going to pick one sock first. The first two questions are really nice and easy, like what you want over what's possible. You can say, well, if I'm going to pick one black sock, well, I have 8 to choose from. Out of all the socks in the basket, there's 32 in the basket, so it's 8 out of 32. I want any of the 8 out of the total of 32. It's going to be 1 over 4. The probability of not a white sock. Well, the probability of not it being a white sock, well, there's 19 white, so there's 8 black and 5 blue. That means there's 13 that are not white. So I want any of those 13. That's what I want. So I want any of the 13 socks over any, there's 32 in the basket. So I'm going to pick out any of those 32, and I want one of them to be white. Or not white, not white. I want one of them to be not white. So I have 13 out of 32 probability. Now, where I have some other information written here. These are basically, you had permutations and combinations the other day. These are combinations, but when it's a combination of 8, choose 1, or 32, choose 1, because order doesn't matter. You just want one sock. It doesn't matter the order. Up top, I wrote, again, our permutation rule, where order matters, and our combination rule, where order does not matter. So these we talked about the other day. Because it's a combination of 8, choose 1, that's 8. 32, choose 1 is 32. 8 over 32. This is really nice and easy when it's that basic. So, 13 over 32. If you put this into the combination formula, 13 factorial over 13 minus 1 factorial is going to be 12 factorial. Those will cancel, leaving you just a 13. So you're just going to get that number. Where the combination comes in a little bit more play is when we're going to pick 2 socks. Now again, the order still doesn't matter because here it's 2 of the same color, or you have 1 black, 1 blue, or 1 blue, 1 black. Order is not going to matter here. So it's combination of 5, choose 2. It's not as easy as putting the 8 over 32 because you have more things going on. Or a combination of 8, choose 1, and 5, choose 1. I'll talk about this in more detail. Over here, I want 2. Let's do this side first. There are 5 blue socks. I want 2 of them. Out of the whole bucket, again, is 32 socks, and I'm going to choose 2. So I do the 5 factorial over 5 minus 2 is 3 factorial. So I counted out 5, 4, 3 factorial over 3 factorial because we're going to divide. And then on the bottom, I have 2 factorial again, because that combination rule reminds me to bring that r back in. 2 factorial is 2 times 1. I don't usually write the 2. On the bottom, 32 minus 2 is 30. So the top is going to have 32 factorial. 32, 31, 30 factorial. 32 minus 2 is 30 factorial over that 2 factorial. So again, 30 factorial will cancel. 3 factorials will cancel. I simplify a little bit up here. Simplify with this 2 and the 32, I end up with 5 over 16 times 31. Well, 5 and 16 reduce. Just keep reducing everything you can. I end up with 5 over 8 times 31. I get 248. My probability of 2 blue socks is 5 out of every 248 times I draw. So, over here, what if I want 1 black and 1 blue? Well, that's going to be a combination of the black socks are 8, and I want 1 of them. The blue socks are 5, and I want 1 of them. Combination of 8 choose 1 or 5 choose 1 is just going to be 8 times 5. So that one's really nice. Combination of 32 choose 2. Again, you do a little bit of work. 32 minus 2 is 30. So 32, 31, 30 factorial over 32 minus 2, 30 factorial. 2 factorial is 2 times 1. Cancel, simplify. 8 times 5 over 16 times 31. I end up with 5 over 62. Okay. Next, we're going to deal with the deck of cards. It's really important that we know the setup of a deck of cards. If you don't have it memorized, I suggest maybe highlighting the edge of the paper or putting a sticky note there. That way you can refer back to it pretty nicely. I highlighted the information. Always assume that when you have card questions, it's a standard deck unless they tell you something fishy is going on with the deck. Assume that it's a standard deck. Okay, so example here. If there are 4 cards are drawn, what is the probability of drawing 2 red face cards? Why does it say 4 cards drawn? I'm going to kind of ignore that. So I'm not doing. So if I feel like this is extra information. I did not do the problem with that if 4 cards are drawn. I didn't do it last year either. I just saw that. So if 2 cards, what's the probability we have a standard deck of 2 red face cards being drawn? So I'm going to say a combination of red face cards. So face cards, there's 3 face cards in each suit. There's 2 red suits, so that means there's going to be 6 that are red. And I want to draw 2 of them. Out of a total of 52 cards, choose 2. So I set this up. 6, 5, 4 factorial. 6 minus 2 is 4 factorial. 2 factorial. Those are going to cancel and simplify, end up with 15. 52 minus 2 is 50, so I go 52, 51, 50 over 50 factorial times 2 factorial. Those subtract out or divide out, and I get 26 times 51. Well, 15 and 51 are both divisible by 3. 5 and 7. You get, what do I get? 5 over 442. Now, this next one, 3 even cards. So I want the probability of, again, I'm picking 3 cards. So out of my 52 deck, I'm going to pick 3, any 3. I want those 3 to be even. So out of those 3, I go up and I figure out how many even cards do I have. I have 20 even cards. And again, I set that up. 20 factorial on top. 20 minus 3 is 17 factorial times 3 factorial. Now, because it's 3 factorial, it's going to be 3 times 2 times 1, which you don't need the 1. That's why I have an extra number now, because I meant to 3. Same thing on the bottom. 52 minus 3 is 49. 52, 51, 50, 49. It's 49, so we'll cancel. 3 factorial, 3 times 2. Now, what's really neat about this, or what I want to point out, is I do a lot of the simplifying as I go, but every single time, if I have 20 times 19 times 18 over 3 times 2, if I have a fraction divided by another fraction, dividing 2 fractions means to multiply by the reciprocal. So I'm going to take this bottom one, I'm going to flip it over, and I'm going to put 3 times 2 up top, and then 52 times 51 times 50. So every single time, those other sets of numbers, and they're probably going to be the same, are going to divide out each time. So I'm going to end up with 20 times 19 times 18 over 52 times 51 times 50, simplifying everything I can, I should end up with 19 times 3 over 13 times 17 times 5, and I get 57 over 1,105. I know I did a lot of this quick because I already had it written out, so if there are any questions, please come back to class or ask me, and I will go over anything. Mr. Christensen will go over anything. But I already had it written down, and my video messed up. I'm going to pause and go to the next page. And I'm pretty sure you guys appreciate if it's a little bit faster anyway. So, here we have a box of 60 baseball cards where 8 contain print errors and 5 are selected at random. So what's the probability that all 5 that I select are going to be one of those 8s that have print errors? How likely do you think that is? That if I'm going to pick 5 cards and 8 of them out of 60, how likely? So I'm going to set it up like this. A combination of, I have 60 cards, I want to choose 5. I want them to be 5 of the 8 errors. That's what I want it to be. So I set that combination up. Here's my steps, 8, 7, 6, 5, 4, 3 factorial, 8 minus 5 is 3 factorial. Then I have 5, 4, 3, 2 up top. 60 minus 5 is 55, so I go out to 55. 5, 4, 3, 2, 1. The factorials cancel at the end, and if you remember how I showed you that flip just a minute ago, those red numbers, the 5 factorials, are going to divide. So I actually end up with 8, 7, 6, 5, 4 over 60, 59, 58, 57, 56. And divide and simplify. 8 times 7 is 56. 6 goes into 60. This is really nice because you end up with 1 up top, and then 59, 29, 57. And then you end up with 1 over 97,527. Okay, so what is the probability that at least 1 has a print error? Well, that is going to be, if it's at least 1, that means the same as 1 or more. So I don't think I discussed it earlier, but the complement. So if it's wins and losses, if you have a 70% chance of winning, you have a 30% chance of losing, because 100 minus 70 is going to be 30. Same thing here. If I have 100%, so 1 minus, if I want 1 print error, well, what is no errors? If I subtract no errors from 1, that would be the complement. So that's going to give you my answer. And no errors, again, I'm choosing 5 cards, so it's the complement of 60, choose 5. And I want out of, well, 60 cards, 8 of them have print errors. How many of them don't have print errors? 52 of them do not have print errors, and I want 5 of them. Once you end up doing this work, and again, I'm not going to do all of it piece by piece, you're going to end up with 1 minus, when I work this out, I'm going to end up with 52 over 60, 51 over 59, 50 over 58, 49 over 57, 48 over 56. Those are your 5 cards. Once you work this out, subtract from 1, it's a little bit of work, you end up with 17,039 over 32,509. Now, if you want to kind of discuss this as a probability or a percent, this up here, we talked about how likely is it that out of the 5 cards you draw, all 5 of them have print errors. This is not a big number. This is going to be less than 1% chance. It's tiny, tiny. It's less than 0.5% chance. It's tiny. This one, when you work it out and you actually calculate it, this one's going to be about 52%. I'm pretty sure this one's about 52%, so this one's pretty likely that you're going to get out of the 5 cards that you draw, you're going to have at least 1. It's a 52% chance. Okay, so the next thing we talk about is odds. Odds is the number of outcomes in an event, what you want, over the number of outcomes not in the event, or the number that you do not want. Okay, so this I always think of what you want over what you don't want. So if I want a diamond, okay, so again, remember it's what I want over what I do not want. I want a diamond. How many diamonds are there in a standard deck of cards? There are 13 in each suit, so I want 13 of those cards. Well, if there are 13 diamonds and there are 52 in the deck, I'll subtract those 13 and that'll tell me how many are not diamonds. So my odds are going to be 13 to 39, which reduces to 1/3. Or you can also write it 1 to 3. Those are both acceptable ways to write that. So what are the odds of drawing one card and it being a number card? So again, go back to that green. How many of them are number cards? Well, you have suits, you have faces, you have letters, 9 numbers 2 through 10 in each suit, 20 are even in the whole deck, and 16 are odd. Those are numbers. 20 and 16 is going to be 36 cards. So a number card means that I want any of those 36 cards. Well, if I want 36 and there's 52 in the deck, I don't want those. I'm going to subtract it. I end up with 36 that I want, 16 that I do not want. So again, I can simplify. I'm going to end up with odds of 9 to 4 or 9 to 4. Both of these are acceptable ways to write that. Okay, so 4 male and 2 female students have been selected for 2 scholarships. If they are to be chosen at random, what are the odds that one will be male and one will be female? So what you probably want to do is you want to figure out the number, like the actual probability. You need to figure out the probability so you can equate it to a number of what you want and the total. So I want the combination of odds that one will be male, one will be female. There's 4 male and 2 female. So out of the 4 males, I want to choose one of them. And out of the 2 females, I want to choose one of them. Okay, so this is what I want to happen. Combination of 4, choose 1, 2, choose 1. We've already talked about these are really nice. That's going to be 2, choose 1. 4 times 2. This is going to be that I want 8 of the combinations that I can come up with. Now the total that could happen is that there are 6 students altogether and I'm choosing 2 of them. So I'm not worried about if they're male or female. Out of the total 6 students, I'm choosing 2. So this is going to be 6 factorial. 6 minus 2, 4 factorial. I'm going to go 6 times 5 times 4 factorial. Remember, you write that one more time. 2 times 1. 2, 6, 3. 3 times 5. I get 15 is the total number. So there's 8 combinations that I want to happen, and there are 15 total combinations. So probability is going to be 8 over 15. What I want over what's possible would be 8 over 15. Now that's not what it's asking. This is asking for the odds. My odds are what I want over what I don't want. So I want 8 of the combinations to occur. 15 minus 8 is what I don't want. 15 minus 8 will be 7, so my odds are going to be 8 to 7. So it gets a little bit tricky that you come up with probability numbers, but you have to turn it into an odds setup. So make sure you read the question thoroughly. Now, the odds, and odds that you go to the movie each week are 1 to 5. What is the probability that you will go to the movie next week? So remember, odds are what you want to what you don't want. And they're telling you that it's 1 to 5. So can you convert that back to probability? So probability is going to be what you want over the total. What you want, 1. The total would be 5 plus that number. So your probability is going to be 1/6. So it's kind of reversing that. The probability of getting all 3 tails when 3 coins are tossed is 1/8. What are the odds of getting all tails when 3 coins are tossed? Well, again, probability. Again, some of you can do this in your head. If you can't do it in your head, I really suggest you write it out each time so you see that process. Probability, want over total. Probability is 1/8. Odds is going to be want over don't want. So it'll be 1/8 minus 1, which will be 1/7, or 1 to 7. And there you go. Those are your odds and probability. Good luck. I know it was kind of a lot and it went pretty fast. So again, if you have any questions, please, please, please come to office hours and see us. Have a fabulous day.